Hello friends, today we are going to learn about relative motion and specific the one-dimensional relative motion and the problem based on the one-dimensional relative motion. So problem number 1, the question statement or the problem statement, two trains each of length 50 meter are approaching each other on parallel rails. Their velocities are 10 meter per second and 15 meter per second. They will cross each other in how many seconds? So in the first sentence, two trains each of length 50 meter are approaching each other on parallel rails. So here from the first sentence, train A and train B both are moving in the opposite direction with a velocity of 15 meter per second and 10 meter per second, and the length of both the trains are 50 meter. So now their velocities are 10 meter per second and 15 meter per second. They will cross each other in how many seconds? So this is the case 1. Now in case 2, both the trains are crossed to each other. So the second case will be here a train B and here train A. The velocity of train A is 15 meter per second and the velocity of train B is 10 meter per second. The relative distance covered by both the trains is 100 meter. So here VA is 15 meter per second, VB is equal to 10 meter per second. Now relative velocity of A with respect to B, that is VAB, is equal to VA minus VB, as both the trains are moving in the opposite direction. So at that time VA is 15 minus VB minus 10, because both the trains are moving in the opposite direction. So as per the sign convention, this is the positive and this is negative. So here VAB is 25 meter per second. The relative distance covered by both the trains, that is D, is equal to 100 meter. So ultimately time taken by the trains, that is T, distance divided by relative velocity. So distance covered by both the trains, that is 100 meter, and the relative velocity, that is 25 meter per second. So ultimately 100 divided by 25 is equal to 4 seconds. So time taken by the both train to the crossed to each other, that is 4 seconds. This is our answer. Now question number 2. An object A is moving with 10 meter per second and object B is moving with 5 meter per second in same direction of positive x-axis. A is 100 meter behind to B as shown in figure. Find the time taken by A to meet a B. So now the initial position from the first statement, an object A is moving with a 10 meter per second and object B is moving with a 5 meter per second. So here one flat surface is there. Object A is moving with 10 meter per second and object B is moving with 5 meter per second. Both are moving in positive x direction and the relative distance between A and B are 100 meter. So it is said as object A is 100 meter behind to object B. Now we have to find out the time taken by A to meet B. Here the velocity of A is 10 meter per second. Velocity of B is 5 meter per second. Now relative velocity of A with respect to B, that is VAB, is equal to VA minus VB. So here VA is 10, VB is 5, as both are moving in the positive x direction. So 10 minus 5 is equal to 5 meter per second. The relative distance of A with respect to B, that is D, is equal to 100 meter. So now ultimately time is relative distance divided by relative velocity. So 100 divided by relative velocity, that is 5. So now question 3, a problem statement. A stone is thrown upwards from a tower with a velocity of 15 meter per second. Another stone is simultaneously thrown downward from the same location with a velocity of 50 meter per second. When the first stone is at the height point, the relative velocity of the second stone with respect to first stone is blank. So ultimately we have to find out the relative velocity of stone A with respect to B. Here assume that the second stone has not yet reached to the ground. So here, as per the first statement, a stone is thrown upward from a tower with a velocity of 50 meter per second. So here this is a tower. Stone A is thrown upward with 50 meter per second. Now simultaneously stone B is thrown down from the same location with a velocity of 50 meter per second. Now stone B is thrown downward from the same location. So stone A is thrown upward and stone B is thrown downward. So here we have to find out the relative velocity of stone A with respect to B. So here VA is 50 meter per second, VB is 50 meter per second. Here stone A is moving in the positive y direction and stone B is moving with negative y direction. So here relative velocity of stone A with respect to stone B is VA minus VB. So ultimately VA is 50 minus VB minus 50, because VB, the velocity of B, is in the negative y direction. So 50 plus 50 is equal to 100 meter per second. So velocity of A with respect to B is 100 meter per second. So this is our answer. Velocity of A with respect to B, this is a 100 meter per second. So now next problem, question 4. Question 4. A thief is running away on a straight road with a speed of 9 meter per second. A policeman chases him on a jeep moving at a speed of 10 meter per second. If the instantaneous separation of the jeep from the motorcycle is 100 meter, so how long it will take for the policeman to catch the thief? So now, from the first sentence, a thief is running away on a straight road with a speed of 9 meter per second. So here, this is a straight road. A thief is running away with 9 meter per second. From the second sentence, a policeman chases him on a jeep which is moving with a speed of 10 meter per second. So here, a jeep of a policeman which is moving with 10 meter per second. So ultimately, we have to find out how long it will take to the policeman to catch the thief. So ultimately, we have to find out the time that will be taken by the jeep to catch the thief. So here, J and T. Now, the individual velocity or the velocity of jeep is 10 meter per second. This is called as absolute velocity. The individual or absolute velocity of thief is 9 meter per second. Now the relative velocity of jeep with respect to thief, that is Vj minus Vt. So here Vj is 10 meter per second and Vt is 9 meter per second, as both are moving in the positive x direction. So both are the positive, so 10 minus 9, it is 1 meter per second. So Vjt is equal to 1 meter per second. Now the relative distance, here the instantaneous separation of the jeep from the motorcycle is 100 meter. So here, this is instantaneous separation is 100 meter. So S or D is 100 meter. So ultimately time T is equal to distance or separation D divided by relative velocity. So D, distance is 100 meter and the relative velocity of jeep with respect to thief is 1 meter per second. So ultimately 100 second. So time taken by the jeep to cross or to catch the thief, that is 100 second. So now, question number 5. Two cars are moving in the same direction with a speed of 30 km per hour. They are separated from each other by 5 km. Third car moving in the opposite direction meets the two cars after an interval of 4 minutes. What is the speed of third car? So here from the first sentence, two cars are moving in the same direction with a speed of 30 km per hour. So this is a car A and car B. Both are moving in the same direction with 30 km per hour. They are separated from each other by 5 km. So both the cars are separated by 5 km. Third car moving in the opposite direction and meets that two cars after an interval of 4 minutes. So the third car C is moving in the opposite direction and meets the car A and car B after the interval of 4 minutes. So here the relative distance is 5 km and the relative time is 4 minutes. So it is 4 by 60 hour. So here ultimately we have to find out a velocity of car C. So now VA is equal to VB is equal to 30 km per hour. Now the relative velocity of A with respect to C, that is VA minus VC. The relative velocity of car A with respect to this car C. Now the velocity of A is 30 km per hour. The velocity of car C, that is VC, but the direction of A and C both are the opposite. So here minus VC, because this is in the positive x direction and this is in the negative x direction. So relative velocity of car A with respect to car C is 30 plus VC. Now we have to find out the time. So the relative velocity of car A with respect to car C, VAC, is equal to DAC. That means the relative distance between A and C, and T AC, time. So distance divided by time. Distance is 5 km and the time is 4 by 60 hour. So ultimately it is 5 into 60 divided by 4, and VAC is equal to 30 plus VC. So 15 into 5, that is 75. So ultimately the car C and the velocity of car C is 75 minus 30, so 45 km per hour. So ultimately, finally, the velocity of car C is 45 km per hour. Now question 6. A bus is moving with a velocity of 10 meter per second on straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what velocity should the scooterist chase the bus? Here, a bus is moving with a velocity of 10 meter per second in a straight road. So here it is a straight road and this is a bus. Bus is moving with a velocity of 10 meter per second. So this is a bus. So VB, that is 10 meter per second. Now a scooterist is chase the bus. This is a scooter A and it chases the bus, and the initial separation of that both the A and B, so initial separation of the scooter and bus is 1 kilometer. If the bus is at a distance of 1 kilometer from the scooterist and a scooterist wishes to overtake the bus in 100 seconds, then ultimately we have to find out VA. So the relative time, that is 100 seconds. So distance is 1 kilometer, that means 1000 meter, and time, that is 100 seconds. So ultimately we have to find out a VA. Now VA we have to find out. VB is 10 meter per second. Now VA is in positive direction and VB is also in positive x direction. So the relative velocity of A with respect to B, that is VA minus VB. Now both in the positive x direction. So VA is as a VA minus VB is 10 meter per second. So VAB is VA minus 10. Now the relative velocity VAB is equal to the relative distance DAB divided by the time, relative time TAB. So here VAB is VA minus 10. The distance is 1000 meter and the relative time, that is 100 second. So here VA is 10 plus 10, 20 meter per second. So ultimately the velocity of scooter A is 20 meter per second. So now question number 7. So in the question number 7, a body is thrown up in the lift with a velocity of u relative to the lift and the time of flight is found to be t. Now we have to find out the acceleration with which the lift is moving up is. So now from the first sentence, a body is thrown up in the lift with a velocity of u relative. So here this is a lift and a body is thrown upward with a velocity of u. Now the acceleration with which the lift is moving, this is A, and the gravitational acceleration is G. Now this object is thrown up with a velocity u, and it is come at the same place with a relative velocity u. So here S separation relative is 0. Now we have to ultimately find out the acceleration of the lift. So here relative acceleration is, this is in negative direction, this is in positive direction. So minus G minus A. Here G is in the negative direction and A is in the positive direction. So we can say as a minus plus A. So relative acceleration A relative is minus G plus A. So ultimately we have to find out only acceleration of lift. So here the time of flight, so upward and downward, the time, that is t. So now separation S is equal to ut plus 1 by 2 at square. So relative acceleration and the relative separation is ut plus half a relative t square. Here the relative separation or relative distance is 0. Why? Because the initial position and the final position of the object is same. So it is 0 ut minus 1 by 2 g plus a t square. So t is cancelled and common, so u minus 1 by 2 g plus a into t, as t is not equal to 0. So 1 by 2 g plus a into t is equal to u gt plus at is equal to 2u. Therefore at is equal to 2u minus gt, a is equal to 2u minus gt divided by t. So ultimately this is the answer, the acceleration of the lift. So expression of the acceleration of the lift, which is 2u minus gt divided by t. So now question 8. Two identical trains take 3 seconds to pass one another when going in the opposite direction, but only 2.5 seconds if the speed is one of increased by 50%. So the time one would take to pass the one another when it going in the same direction at their original speed. So here from the first statement, two identical trains take 3 seconds to pass one another when going in the opposite direction. So two identical trains, that means this is a train A and this is a train B. Both are the identical trains and moving in the opposite direction. and it will cross in 3 seconds. This is a case 1. So here relative velocity of train A with respect to B is VA minus VB, but here the train B is moving in the opposite direction, so VB considered as a minus VB. So here VAB is VA plus VB. Now the relative velocity of A with respect to B, that is VA plus VB, and the other expression is the relative distance divided by relative time. So here a relative time is 3 seconds, so VA plus VB is D divided by 3. So D is equal to 3 into VA plus VB. So it will becomes 3 VA plus 3 VB, equation number 1. Now 2.5 seconds, if the speed of 1 is increased by 50%. So here case number 2, the speed of A is increased by 50%. So here train A and train B, speed of A is increased by 50%. So here it will become 1.5 VA and this is a VB. So 50% increased speed, that means VA plus 0.5 into VA, so it will become a 1.5 VA. So now in case number 2, a relative velocity of A with respect to B, that is VA minus VB, so it is VB, but here the VA is 50% increased, so it is 1.5 VA plus VB, that is distance divided by time. The time taken by the crossed to B, that is 2.5 seconds in the second case, so D by 2.5. So ultimately D is equal to 2.5 into 1.5 VA plus VB, so it will become 3.75 VA plus 2.5 VB. This is the equation number 2. Now this is the first equation of D, this is the second equation of D. So we compare both the equation, compare 1 is equal to 2, so it will become 3 VA plus VB is equal to 3.75 VA plus 2.5 VB. So here 0.5 VB, because 3 VB minus 2.5 VB, that is 0.5 VB, 3.75 VA minus 3 VA, so 0.75 VA multiply by 2, so VB is equal to 1.5 VA. This is a equation number 3. Now in case number 3, we have to find out the time one would take to pass each other when going in the same direction. at their original speed. So at their original speed, if the both trains are moving in the same direction, then we have to find out ultimately the time. So here VB is 1.5 VA. So VB is more and VA is less. So in the chasing condition, VA is moving forward and VB is moving backward. So here in case number 3, when both the trains are moving in the same direction, at that time here the direction is same. Here the VB is 1.5 VA. So VA is less and VB is more. So B and A. So expression VB is 1.5 VA. So here we have to find out time t. Now the relative velocity of train B with respect to A, that is VB minus VA. So VB is 1.5 VA minus VA, as both are moving in the positive x direction. So VBA is equal to 0.5 VA. Now here we have to find out a distance which is from this expression. D is equal to 3 VA plus VB. So here VBA expression is in terms of VA, so we have to find out the distance D is also in the expression of VA. So VB is 1.5 VA. So 3 VA plus 1.5 VA. So distance is becomes this 1 plus 1.5, 2.5 into 3. So 7.5 into VA. So here both VBA and distance are in the expression of VA. So now as per the case number 3, time is distance divided by relative velocity. Here the distance is 7.5 into VA and the relative velocity VBA is 0.5 into VA. So VA cancel, 0.5 divided by 0.5, that is 15. So time is 15 seconds. So as per the case 3, if the both train are moving in the same direction, then the train B is crossed by train A within 15 seconds. Thank you.